Sir,
Yes.
Sir, can you please provide the recording for yesterday?
yes,
No,
sir.
yesterday I could not. I forgot actually. No,
Sir, I
forgot.
made
I
this
had some
actually.
work. I forgot that.
Okay, sir. Okay, sir.
Otherwise, there is no issue. Today after 2:30 you will get both the one. Okay.
Okay, sir. Okay, sir.
Sorry, sorry.
Yes, sir.
I forgot to upload.
सर हेलो सर
हाँ.
सर वो QEMU का इंस्टॉल नहीं हो रहा सर इसमें
क्यों इंस्टॉल नहीं हो रहा है? उबुंटू में
वो-
नहीं हो रहा है?
सर वो कौन सा कमांड देंगे वो ये ऐप इंस्टॉल QEMU के और
sudo apt get install.
Install QM.
Sudo apt get install.
उसे
QEMU.
क्या सर हाँ QEMU के सर
ये तो नहीं हो रहा है. हाँ.
हाँ सर नहीं हो रहा
ओके एक बार अपडेट करके देखिए. एक बार आपका उबुंटू को अपडेट कर दीजिए फिर देखिए. केमू तो इंस्टॉल हो जाना चाहिए. केमू तो नॉर्मल सॉफ्टवेयर है.
ठीक है सर ट्राई करता
वो ट्राई कीजिए. नो प्रॉब्लम. वन डे आल्सो you start looking into this XB6. I have sent one video also. In that video you can know how to create a command, I hope, and how to create a system call. So by that way you try this food algorithm. And I asked for giving me the group number so that I'll update in the module. And when you submit it, group wise you have to submit it. Okay, you just everybody please prepare a group and send it to me. Don't make it overlapping groups. Okay, maximum 11, not maximum 11, minimum 10, maximum 11. That you make it minimum 10. Otherwise, it will be very difficult. Yes, so that at the end you can do very nice programs in the XB6.
सर ये सर स्क्रीन शेयर करूँ वो नहीं हो रहा QEMU
Later it is okay if Kemu's installation, if it is not working, I'll do it later.
ओके सर
Okay, today's class will first progress because in other section I found that they have started this multi-level feedback queue. We are really like 2 classes. I think we are behind running. If needed, I'll request all of you, because another 2 minutes are there. One or two extra classes I may take sometime before March. Not now, if it is required.
Okay, sir.
Okay. Otherwise, I'll not take any extra class. Because I spent some time in this programming, and that's the reason we are going slow. Otherwise, we are in the same pace of the other classes. Fine. So we're planning to start now. So this one you have done. Practice is necessary, please. So we studied that what is the what are the different criteria. I hope you have remembered the turnaround time, response time, and waiting time, CPU utilization, and throughput. So this basically required for when you are designing any scheduling algorithm. By this 5 criteria, you can verify that your algorithm is proper or not. Okay. Then we first studied the algorithm as basically 2 types. One is the preemptive and non-preemptive. In case of non-preemptive, currently we are studying only the non-preemptive algorithms, where once the process enter into the CPU, he can himself come out, but nobody else can forcibly take him out from the CPU. Okay, and then we have studied first FCFS. The FCFS is mostly the batch-oriented jobs, or kind of jobs has to be executed in FCFS. Because if it is a larger jobs, everything is every jobs are a very huge huge size. In that case, the way they are coming, in the same way you start executing. So it will maintain a queue. From the queue, whoever has come to the beginning of the queue, he will execute first. But we are finding, because of this CPU burst times of each of these processes, if you can start with the smallest size processes first, then the waiting time gets reduces. Means in our FCFS, basically average waiting time is quite high, because they are not looking into which process is a heavy one and which process is a light one. So to avoid this average waiting time, we go for this SJF. And in the SJF, we are finding that the lowest means lightweight jobs will be executed first, and then the heavyweight jobs. So that the heavyweight jobs has to wait for a lesser time as compared to the previous cases. And one observation somebody has identified in the last class, that is, while implementing the SJF, it may not be a realistic. The reason is that you are applying this SJF based on the CPU burst time. But before running this algorithm, nobody knows how much time this process will take. Only you can make a guess that it is happening. So that's why it is not mostly realistic. Then what is the why you are learning these things? The next question arises. If it is not realistic, only for the sake of it is giving best result, you are doing it? No, not at all. Because when you apply this shortest job, always the shortest job algorithms will perform better. Then what they have studied, when you compare these 2-3 algorithms, then which one is better? Yes, then you have to compare that algorithm with the shortest job algorithm. Whichever the algorithm is nearer to the shortest job algorithm's performance, that algorithm is better. Because we always know that the process which are lightweight, if they will execute fast, your turnaround time, everything gets reduced a lot. We are finding it here, this turnaround time reduced from the 43 to 21. Here we have reduced from this 25 to something here, reduced. Means it is always performing better. So what they are saying, for the comparison purpose or to identify that which algorithm is better, for that they are comparing those algorithms with the SJF. Because once you know these are my processes and these are my CPU burst time, and if you can calculate what is the turnaround time, response time, and waiting time, this result you compare with other algorithm you can apply with the same data. If they are nearer to this, means those algorithms are better. For that purpose, basically we are using the SJF. But later we'll see how the SJF can be achieved in a real environment. That is, we'll study during the multi-level queue, feedback queue scheduling. But currently it is this. Yes.
Sir, but nowadays we are using, sir, we are not bothered about that, how much time it is taking. About that priority we are bothered, no?
No, priority it is coming, but the priority is also important. I'm saying even if it is a priority based scheduling, if we can say that almost all priorities are very nearer, and after executing these things, what is the performance of this priority scheduling also? The next topic comes the priority scheduling. If it is nearer to this, we can find that it is better. That's the only comparison. Otherwise, there is no such comparison why this SJF is used. Basically, SJF is not at all used in the real environment.
Sir, like a benchmark.
It is a benchmark, you can say. Fine. So, well, 1 minute. Why my 1 minute? Mic is not working. Just a minute. No. Yes, is it audible?
Yes, sir.
That's fine. So we'll start with this. So next important one is coming us. So all these are the preemptive, non-preemptive one. So let's go for one preemptive one. The preemptive one is called as the shortest remaining time first algorithm. So it is the shortest job, but what is saying? It is a preemptive one. So let's take some data. The data is basically we are considering P1, P2, P3, P4, and arrival time is here 5, 0, 0, and 3. and CPU burst time is 2, then 11, then 10, and then 4. Okay, this is this. So I am doing it. What is SRTF? So this is called as SRTF. What it does? He's saying I am preparing this Gantt chart. So first, which one will be executed as per this view? Both of them are coming first. Since both of them are coming first, here one observation is coming that since both the processes are arrived at the same time, in that case, whichever is less execution time, that will be executed first. So P3 first enter. How much time it has to be executed? In SJ, it has to be executed for the whole 10 hours because there is no preemption takes place in the middle. But in this case, what happens here? You have to verify after how much time the next process is coming. The next process is coming at 3 o'clock. Means maximum you run up to 3. Okay. So if it is run up to 3, how much time is left? 7 units. Now this has arrived. At 3 o'clock, this has also arrived. Then how many processes are currently present in the ready queue? 2 processes. One is this, one is this. What is the execution time of this? 7 units. Rest required. What is the execution time for the required? 4. Means what happens now? This 4 is going to be executed. So P4 enter. Means
5.
P4 now. This is P1, P2, P3, P4. It has executed from the 0 to 3. It has reached at a 3.
3 to 5.
3 to 5 hours. No problem. So it is executed for the next process when it is arrived. So next process arrive at 5 o'clock. So up to 5 you run it. So if it is up to 5 means 2 units. If it is 2 units is running, then 2 units has left. Then all processes arrive. Since all processes arrive, which one is the less execution time? If you can look into it, this is 2, this is 2. Both of them are 2. So when in case of SJ, if both the processes has the same execution time, then you have to say which one is come first. So which one is come first? This P4. So the P4 again executed. For how long? For the whole 2 units it has to be executed. So 5 to 7, then it becomes 0. Once it is 0, then 7, 11, 2. So this will be executed P1. P1 will be 2 units. 2 units means 7 to 9. So this goes to 0. Then it is 7 and 11. So P3 again executes for the 7 units. 9, 7 is 16. So this goes to 0. So this is complete. This is complete. This is complete. Only this is left. That is 11 unit. That is P2 is 11 unit. So this is 16 plus 11 is 27. Are you getting? So this way you are doing. So what you have to do? The process is very simple. First you put a process. Then you check who is coming next. Up to that much you execute. Don't execute fully because it is a preemptive one. Because of preemption, this P3 has to be forcibly taken out and P4 is entering into this entering for the execution. So this part is basically preemption. That's why it is saying shortest remaining time first. Means whatever remaining time was there, among this all remaining time, you are finding which one is the shortest and applying this process. Can you quickly calculate what is the turnaround time and a response time and waiting time? Now you can find a difference between the response time and waiting time. Because previously it is a non-preemptive one, so always it will be same. Now you find out what is the turnaround time, response time and waiting time. Do it quick.
The first one will be 9 minus 9.
Yes. So how you are, those who are not able to get it, please look into it. Turnaround time means when it has submitted, when it has completed. So the completion will start at this end. So P1 करके कहाँ complete हो रहा है? यहाँ 9 पे. So directly 9 minus 5. So this becomes 4. So P2 27 पे complete हो रहा है. So 27 minus 0 becomes 27. Then P3 16. So 16 minus 0 becomes 16. P4 7. So this 7 minus 3 becomes 4. Okay. Got it? This is it. Similarly, response time कहाँ से शुरू होगा? यहाँ से. Okay. When it has come and when it has started. So P1 is 7. So 7 minus 5. Because see, it has come at 5 o'clock, start at 7 o'clock. So how much time it has to wait? 2 minutes. And similarly, P2 P2, 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 16. Very nice. So this 16 minus something 0 is become 16. P3, P3, P3 are 0. So 0 minus 0 becomes 0. P4, P4 is coming at 3. So 3 minus 3 becomes 0. Okay, this is our so waiting time. What is the waiting time? How much time it is turnaround time? So turnaround time is 4. काम कितना किया है 2 घंटा. So 4 minus 2 becomes 2. Then his turnaround time is 27. काम कितना किया है 11. So 27 minus 11 will be 16. Then turnaround time कितना है 16. So 16 minus 10 is become 6. Then turnaround time it is 4. And how much time he has worked? 4. So 4 minus 4 becomes 0. Got it? So in this way, you can make a shortest remaining time first category. Okay. So one you can try, one more you can try. If I'll give it. So let's it is P1, P2, P3, P4, P5. Arrival time is 2, 1, 4, 5, 8. Okay, and execution time is CPU burst time is that is 7. Then it will be become 5. Then it will be become 1. Then it will become 6. Then it will become 2. Can you calculate the Gantt chart and this so that once it will complete, we'll go for the next one. Quick. Everybody do it. Even if error, देरिए मत. Practice हो जाएगा देखिए, मजा आएगा. कुछ चाहिए turnaround time, response time, waiting time, and then prepare a chart. Then
Yes, sir. Sir,
Okay.
first
Okay.
0 to 1
I
is
will do it, then everybody will compare with them. Others, please response at least 4, 5, so that you understand that you have done. Yes. Others are able to do it. Anybody else?
Chart is done.
Chat is done. Chat is done. Okay, very nice. Any other student? Why only 2? Not understanding, I think. Okay, I'll explain one second how it is. So who has come? This has come at 1 unit. Means at least 0 to 1, we are not doing anything. Yes, at 1 o'clock he has arrived. So I put a tick mark. So who is now going to be executed? P3.
P3.
What I told? I simply told that after this one will be executed, you check next to who is coming. This is coming at a 2. Means maximum you can run them for 2 units. 2. So how much unit has executed? Only 1 unit. So this is become 6. 6 is left out. Then comes for next. Who has arrived at a 2? He has arrived. Then how many processes presently current in the queue? P1 and P3. So P1 takes requires 6 unit and it requires 5 unit. Since it is required 5 unit, then immediately what is going to happen? This P1 is now going to be executed. How long? You are going to execute it for the next arrival. The next arrival is at a 4. So 2 to 4 means 2 units. 2 unit if it is gone, 3 is left. Okay? 3 is left. Then what is the next one who has arrived? P2. So I just put a tick means he has arrived. Then what is the execution time? He requires 3, he requires 6, he requires 6. So P will be executed. So if he will execute again, P1 will be executed. How long? Up to next arrival. So next arrival is at 5. So since it is becoming 5, so up to 5 it has executed means 2 units left. Because 1 unit has executed, only 2 units, then another 2 units left. Because here 2 units, here 1 unit, 3 units gone. Out of 5, 3 units, if it is gone, 2 units are left. Okay. So after this, how many are present in the ready queue? P1, P2, P3, P4. And among this, which one is the lowest one? This is P3, P4 is the lowest one. Just look into it. Because it is 1 unit, it is 6 unit, it is 6 unit, it is 2 units. So which one is less? P4. P4 will be executed. Because it has only 1 unit. So it has to be executed only 1 unit. So 1 unit means 6. Then it goes to 0. Then it is completed. So now what is the time? 6. At 6 anybody has arrived? Nobody. Then who are present in the queue now? 6, 602. So we will execute next. Again will be executed. How much? Minimum to maximum up to this 8. Because next process is coming at 8. So he requires only 2 units. So 2 units means 2 units is 6 to 8. And it is completed. Since it is completed, I can. And at 8 o'clock, who has arrived? This fellow has arrived. So I'll put a tick. Now who are there? This is 2, this is 6, this is 6. So all have arrived. No need to check anything. Whoever has less, first you put it. So P5 is less. Then 2 units, it is 10. So it is over. Comes to 0. Then P2 and P3, both have the 6. If it is as per the SJP, both of them are the same execution time. Which one will be executed? Who has come first? FCFS. Okay. So FCFS means P3. So P3 will become 6 units. 6 means 16. So this becomes 0. This is cut. Only this is left. That is P2. And P2 will be executed for 16 plus 16 is 22. समझ में आया? Are you getting?
Yes. Yes, sir.
So turnaround time जल्दी निकाल पाएंगे? सब लोग आप लोग कीजिए आपका पेन एंड पेपर में इसको देख के जस्ट यू लुक इनटू इट एंड प्रिपेयर दिस P1, P2, P3 टर्नअराउंड टाइम. Those who have not done. Okay? Just 1 minute दे रहा हूँ. 1 मिनट में टर्नअराउंड टाइम कंप्लीट कीजिए. यहां से देखोगे. हाँ, यहां से कब कंप्लीट हुआ है वो वाला प्रोसेस. सपोज P1 को देखते ना. P1 कब खत्म हुआ है? यहां से देखिए P1 यहाँ 8. So this is 8. आया था 2 बजे. So 8 minus 2 becomes 6. Like this you put it quickly. So that आप डरोगे नहीं. एक क्वेश्चन गारंटेड देखिए 10 मार्क कम नहीं है. मिड सेम में भी एंड सेम में भी. थोड़ा सा डिफिकल्ट वाला आएगा और धीरे धीरे हम जाएंगे क्योंकि हम अभी तक एसआरटीएफ भी आता है डायरेक्ट 2-3 मिला के होते थे. एसआरटीएफ करो, एसजेएफ करो और एफसीएफएस करो और प्रायोरिटी 2-3 मिला के. डन? फिनिश?
Yes, sir.
Yes.
P2 का देखिए 22 पे खत्म हुआ है. सो 22 minus 4 आप लोग करोगे कितना? 18 है. देन P3 हमारा 16. यहाँ देखोगे बस डालोगे 16 minus 1 so 15. P4 is 6. So 6 minus 5, 1 unit. Then P5 is 10. So 10 minus 8 becomes 2. Complete. Similarly, response time कहां से? इस साइड से देखेंगे. क्योंकि कब आया था, कब वो शुरू हुआ है. So P1 कब शुरू हुआ है 2 बजे, so आया था कितना बजे 2 बजे, so 2 minus 2 becomes 0. Then P2 कब शुरू हुआ है, P2 16 पे शुरू हुआ है, so आया था कब 4 बजे, वो बहुत टाइम वेट किया है वो वाला. Then P3 1 बजे शुरू हुआ है, 1 बजे भी आया था, so 0 unit. Then P4 शुरू हुआ है 5 बजे, 5 o'clock, 5 minus 5 becomes 0. So P5 has started at 8, so 8 minus 8 becomes 0. Very nice response time. Okay, almost all of them are 0 and this is only 12. Then waiting time is this turnaround time, कितना घंटा रुका है, कितना घंटा काम किया है. So 6 घंटा रुका है, 6 minus 5 is 1. Then A 18 घंटा रुका है and काम किया है 6 घंटा, so 18 minus 6 becomes 12. He has worked for 15 hours, stay for 15 hours, work for 7 hours. So 15 minus 7 becomes 8. Then stay for 1 hour, work for 1 hour becomes 0. Stay for 2 hours, work for 2 hours becomes 0. Yes, you can find the average. Got it clear? Yes, this is the way to do it. One you can do it later, that I am just giving you two more, so that one more you can try with this later, not now. So P1, P2, P3, P4, P5, and arrival time is, that is 5, 1, 0, 7, 6, and execution time is, let's take 2, 6, 8, and 4, and 1. Okay, this is one. Another one you can try for this. Suppose arrival time and execution time. One more questions. So let's take it is same 5, 1, 0, 3, and 5, and it has arrived. This is execution time is 2, 3, 9, 4, and 2. Okay, these two questions you can try with SRTF. Yes. Yes.
सर एक डाउट है कि सर वो नाइसनेस और वो प्रायोरिटी में अंतर क्या है?
Niceness and priority, yeah?
Yes sir.
Nice command, NICE command you are saying, no?
Yes sir.
Nice is a command which will be used to change the priority of the process.
Okay sir.
Okay. So this you have studied how the SRTF work. But what is the observation you are finding? Our SJF is not realistic, but SJF is performing always better. That's why what they thought, why don't you predict this execution time? Is there any way to predict the execution time so that you can apply the SJF there also? So for that prediction, they thought about one approach, that there is a formula called as S of n plus 1 is equal to alpha for T of n plus 1 minus alpha into S of n, where S of alpha is considered as a weight, and this weight will be varied from 0 to 1. So you can say it is alpha is greater than equal to 0 and less than equal to 0. Think that it is a probability, means with the alpha probability it is taking some Tn. With 1 minus alpha probability, he is taking term Sn. So first you know what is Sn and this. So Sn plus 1 is nothing but the predicted CPU burst time. Predicted CPU burst time, yes, of the next process. Yes, and your Tn is actually the actual CPU burst time. Actual CPU burst time of the PN process. Yes, what does it mean? This meaning is saying, when you want to calculate what is my next process's predicted time, he is saying, you know about my previous process's actual time and a previous process's predicted time. So if you can calculate this one, if you know these things with a certain probability, you give alpha weight to him and 1 minus alpha weight to him, then you can predict that what is the next one. So what is this alpha weight? Suppose the alpha weight is 0.9 and this will become 0.1, means while computing this predicted time of the next process, you are more importance to the actual time. Means whatever my current actual time, your predicted time is mostly depending upon that. So that is basically observation. If you observe that whatever the actual time, always my predicted time nearly equal, in that scenario, you give more probability to this alpha, and 1 minus alpha similarly reduces a lot. If you can think that my predicted time is basically depend upon my last predicted time, then you give more to this and less to this one. So in that way, you can think of there is one chances of finding the predicted time. Let's take a small example and finding this how it is working. Okay, so if you can consider this is a P1, P2, P3, P4, and P5, and let's assume their actual timing is this is 2, then it is 12, then it is 5, then it is 4, then it is 6. Okay, this is the T of n. Okay, so we have to find this S of n. You have to find the S of n. But the formula says this is your Sn plus 1 is nothing but alpha for Tn plus 1 minus alpha for this is Sn. So if you can think, I want to calculate it, what is S of 1. This is basically your alpha for S of T of 0 plus 1 minus alpha for S of 0. But T of 0 may be the first process that you can know. What is my first process's execution time? I can compute this one. But this requires my previous predicted time. Because this previous predicted time with this actual time, I can predict a new time. Because if you can consider, this is become my previous predicted and this is become my current actual time, then I have to compute this S1 is my predicted time. Now, I can get this actual time after completion of the P1. But what about my previous predicted time? They are saying this previous predicted time is calculated based on my previous time when the CPU was running with n number processes. What was the total time, average time was coming. Suppose previously there are 10 processes are running, P1, P2, P3, P10. Then this process requires 5 unit, 9 unit, 7 unit, 6 unit, 8 unit. What they'll do? They'll find the average of this. Whatever the average time they are getting, that is my initial predicted time. So if you can know this initial predicted time, you can able to calculate it. What is this? Let's assume that previously initial predicted time becomes 5. Then what will happen? 5 plus 2, and what is alpha? The alpha can be taken as a 0.5, or usually we can take the 0.5, half probability from this, half probability from this. If you can take here alpha is equal to 0.5, then you can compute this one. This one compute by 0.5 into T0, 2 plus into this, which is nothing but a 5 plus 2 by 7 is 3.5. Again, this 3.5 and this 12 will be added. So 12 plus 3 is 15, 15.5. 15.5 means how much by 2 it will become? 7.5, 7.75. Then again 7.5 plus 5, that is 12. So 12.75 is nearly comes as a 6.37 or 38. Then 6.38 will be added. So this will be becomes as a 10. 10 means 5.19. Then 5.6 will be 11. 11 is 5.5. 5.5 with the 9. 5.5 with the 9 means 9.5 means 6. Sorry, कितना होगा? ये थोड़ा calculate गलत कर दिया. 5 plus 6 is 11. So 11 means 5.5. 5.5 plus 0.9. So 5 plus 0.9 is 5.59. Okay. Yes.
सर वो 3.5 plus 12 तो 15.5 आएगा ना?
This is 15.5 by 2, no? Because you are calculating like this, no? This 12 is the actual, so 0.5 into 12 plus 0.5 into 3.5. Got it now?
Okay.
So this is nothing but a 0.5 into 12 plus 3.5. Yes, that. Just for the calculation, simplest calculation, I have just done like this. So based on this weight test, we are finding what is the predicted time. But this predicted time is not appropriate in all scenarios. Why? Because if it is somehow coming in the same pace, then it is good. But if it is coming in the different pace, you cannot say that all are correct. You cannot predict. Actually, you can see it is coming 6, but actually it is coming 4. It is coming 5, it is nearly coming 6. Here it is looks like a similar. But think, first process is 2, next process is 12, next process is 100, next process is 4. So you cannot predict properly. Since almost all are nearly equal to 12, 5, 4, 6, you think that my prediction is also nearly equal to my actual. But if you think it is 2, it is 12, and it is become 500, then can you predict actually what should be the next predicted? It comes as around 250, but whereas it is coming as a 4. So that's why always it is not proper. But in certain senses, if you can, one can think that no, I want to calculate it with the predicted one. This is the approach to. Okay.
Sir, but sir, we are calculating the predicted time in S1, let's say, and sir, then we are executing the P1 process. We get a time which is actual. And we should compare it with the result so that we can alter that alpha.
No, that is a different approach. You can change it. It is the simplest one. I have just taken as a alpha will be a constant. Alpha is the constant for the whole time period, and this is the approach. One can say that after calculation of 10 such processes, my alpha is has to be changed depending upon what kind of a difference is coming. So I'll calculate the difference, and find out a new alpha after 10 such processes calculation. One can also think in that. Okay, I'm not saying this is the one, but some weightage you are giving here, and based on this weightage you are finding this. If my weight is completely 1, means my actual time is equal to my predicted time. If this is become 1, means my predicted time is equal to my last predicted time. It is not at all depending upon this actual time, because it is just a probability. So with what probability you are choosing this actual time, with what probability you are choosing this one. Okay, that's fine.
So then we have to store this as that previous time record.
Obviously, we have to store it. And storing is very normal, because one can easily say that how much time my last 10 processes have executed. It is very easy to store.
Okay, sir.
अभी कुछ आ रहा है?
Sam left the meeting, I guess. Network issue के लिए.
हाँ नेटवर्क इशू होगा.
Yes, from my side, the power cut has happened. Sorry. Is it visible now? Hello?
Yes, sir.
Sir. So that I told that it is based on this predicted one, we are calculating this. So this is one approach is that. One can ask that what is the predicted time, you can easily explain with this formula. Then the next important one, which is currently used in many operating system, that is called the priority scheduling algorithm.
Why are we assuming that T0 will be equal to T1?
Why not? I'll accept that T0 is equal to
P1, sir. P1 ka T1.
I taken this one, no, because T0 will be the P1 I took. Then I took this S0 will be something which was calculated prior to this. Then I have taken also. T0 equal to 2 here. Yes or no?
सर वो तो 0th प्रोग्राम का है ना 2 तो.
वो मुझे पता चला. ये आपका 0th, बट यहाँ पर 0th प्रोग्राम कौन होगा? ये वाला होगा ना. As per our figure, this will be my 0th program. But what is my predicted one? The predicted one I will consider the previous one. Because any one has to be taken as a previous one and one has to be taken as the actual one.
Okay.
Yes or no? So I took this is my actual one, and even if the formula says it is a T0 and S0, one can say that sir, this is T0 hoga to ye to S0 hoga. Then why you have taken this one? Because one has to be taken from the previous, one will be the actual, so that you can calculate the predict one for this. Okay. In that basis, you have to. Yes. So next comes the priority scheduling algorithm. So in this priority scheduling algorithm, there is one extra parameter is given. Every process has a priority, and whichever has the highest priority, that is going to be executed. And this priority scheduling is mostly the preemptive one. Okay, preemptive one. But the question during the your exam, one may ask that it is also non-preemptive one. Non-preemptive one means whichever the process has currently highest priority, once it is becoming entering, nobody can take him out. Like we have studied SRTF and SRTF. In SRTF, rule is same. The process which has less execution time, that will enter into the CPU first. But in one case, once a process enter, you cannot take him out in the middle. In another case, even if a process enter into the CPU, if a new process comes with a less execution time, then the current process has to be come out. Here also the same thing will be happening. If a process, if this is my CPU, yes, if P1 process is currently executing with a certain priority, if a new process comes, in case of a non-preemptive, nobody can take him out because the P1 has to be completed, then only it has to come out. But if it is a preemptive, even if this P1 is partially executed, because of this P2 which has a more priority, this has to be taken out and this will be entering into this. Okay, so that's why mostly we will go for the non-preemptive one. Non-preemptive one, it will come, it will be very easier for you. I'll tell you how to do this non-preemptive one. But here I am going to show you how to make a preemptive one. So let's take P1, P2, P3 and P4. And the priority are given as a 2, 3, 1 and a 2. And in this scenario, consider in the question always you mark what is written. They may give a minimum number is the highest priority. Highest priority. If it is given like this, you have to consider this is highest priority, then this one. Okay, please look into the questions carefully when you appear the exam. If they say that maximum number is the, if there,
question.
it will mention in the question. If it is not mentioned in the question, on the top you write a note like this, that I consider that the minimum number is the highest priority or maximum number is the highest priority. You write it and answer it. Okay, there is no such provision that there is a fixed thing is not available. So arrival time is 3, and let's take it 0, then it is 4, then it is become 5. And execution time of this processes are 4, then 6, then 2, then 5. Okay, now I am preparing how they are executing. So please look into it. I hope you understood this. So first you have to always look the arrival time. The arrival time is 0. It is means P2 has first arrived. So first P2 enter. Yes. Because only one process means no need to look into the priority. First I'll execute it. How long I'll execute? Always processes up to next. Up to next matlab कौन है? This 3 में आ रहा है. It is at 3. So up to 3 o'clock at least you can run it. So how much unit left? 3 units left because 3 units has run. Then who has arrived at 3 o'clock? This fellow. Now you look into it. Among now 2 processes are present in the ready queue. So which process will get a chance to be executed? This one. Because we have taken here minimum number will be the highest priority. Means 2 is highest. Since 2 becomes high, who will execute now? See, this P1 will be start executing. How long? Till next process comes. So when the next process is coming at 4 o'clock, means only 1 unit has executed. So how much left then? 4 minus 1 is 3. Yes, if you are not understanding, please ask me. This is 3. Now what is the next one then comes? Now who has arrived at 4 o'clock? This. I just put a tick. Tick means these processes are currently present. If these processes are currently present in the ready queue, who is going to be executed now? This is
P3.
Very nice.
Minimum.
P3. Very nice. P3. Then P3 will be executed for how long?
Right.
Next process. Up to next process is this. So 1 unit. 1 unit means only 1 unit left, and this has arrived. Now all have arrived. Since all have arrived, who has the highest priority? This fellow has the highest priority. And what is going to happen? It is going to happen P3 again execute. How long? 1 unit. 1 unit means 6. Now it is 0. I got it. Got means it is completed. Now next 2, 3, 2. Which has the highest priority? This one and this one. If both of them are the same priority, please remember, if 2 processes have the same priority, then you have to think about SJ. So the sequence is like this always. First you have to look into the priority. If priority is same, then you have to go for the SJ. If both of them are the execution time is also same, then you have to go for FCFS. Then you can say, sir, if both of them are come at the same time, then you can say as per the writing. As per the writing. Hey, don't write this, just for the sake of saying it. As per the writing means if P1 and P2 written like this and their arrived time is 0 and 0, then who one will be executed? We are thinking this because P1 pehle likha gaya na, usko pehle. But there is no such rule. You can write first P2 then P1 because both the arrival times become 0. But the rule is first you take a priority, then if priority will be same, then SJ. If both execution time will be same, then FCFS. If both come at the same time, then the way you are writing, you follow or any order.
Sir, if the last case that FCFS to the other state where same time they're arriving, sir, there the system can halt also.
No, wait. If the same time, but as per the system is concerned, can you think that at a 0 o'clock 2 things will be happening? Never. Never. But just for the pen and paper writing, we are writing 0. But it never happens that at exactly at 0 o'clock, 2 or more than 1 thing will happen. It will never happen. Okay? That's the point.
Yes,
So once it is done, then what is the next one comes? Who will execute next? P2, P1, P3, it is over. So P3 gets completed. Then among two, both of them are the same priority. If both of them are same priority, which one is the less execution? This is 3,
P1.
5, P1. Very nice. P1. So P1 will be executed for rest because it is a high priority. So 9. Once it is completed 0, then it is completed. Now you have a P2 and a P4. P2, P4, this is high priority. Then P4 will be executed. How long? 5 units. 9, 5 is 14. So this is become 0. Then who is left? Only P2 is left. So the P2 is becoming 3 units means this is 3 units.
17.
Okay. So in this way, you can able to calculate that which one will be executed when. Yes. So first P2, then P1, then again context switching is happening. Then P3 continuing, again context switching is happening to P1, again P4 enter, again P3. Okay. So in this manner, this priority scheduling is. But one problem comes in the priority scheduling. That is called as, what is the problem? The problem is, suppose a high priority jobs, a low priority jobs first comes. Okay. Suppose a sub-staff has come and stand in the queue for the buffet system. Okay. Immediately after some time he was taking the food. That time one clerk has come. Actually, so obviously he has the high priority. So you leave him, hey, you please take. When the clerk is taking, no, at the same time one more high person is coming. Suppose one BDO or SDO has come. So he will take again. Then when he was taking, another collector has come. So collector will take. Then what happens? The person who has come first, he has to starve for a longer time. Because of this preemptiveness, the low priority process which has come early, but they could not get a chance to be executed by the CPU. Because after that, one more process comes who is higher than this. After some time, when that higher priority process executing, one more higher priority comes. Because of this high priority comes gradually coming, the lower priority process never get a chance to be executed by the CPU. So that scenario is basically called as the starvation.
Aging.
Yes. So this is called as starvation. And how to avoid this starvation? The starvation will be avoided by a technique is called as aging. What is the aging? The aging is basically says that you have to increase the priority of the processes which are weighted processes by 1 unit after a fixed time interval. After a fixed time interval. What does it mean? He's saying, suppose P1, P2, P3, P4 and P5. Their priority, assume the priority arrival first, right? Arrival. The arrival is, let's take it as comma 0. This comes as a 2. This comes as a 3. This comes as a 5. This comes as 2. Okay, like this. And he has come and his priority is, let's take it is 6, little high. But after that, this fellow, this 2 are coming. His priority will be, let's take it is 4. And this becomes a 7. Okay. But again, it is coming. This fellow's priority will be 2. And this fellow's priority will be 1. Yes. And some execution time is there. Let's assume that it is a 7 unit, this is a 3 unit, this is a 4 unit, this is a 1 unit, and it is of 3 units. This is the execution time. What is the problem? Where this starvation comes? If you can look into this chart, basically, so first this P3 comes, enter. So the P3 is arrive at 0 o'clock and it starts executing. After some time at 2 o'clock, these two processes arrive, P2 and P5. So 0 to 2 he has executed. Thoda sa khana khaya hai, 2 spoon khana khaya hai. Then this processes have arrived. So he has to change it to 5. Only 5 minutes are left. But now this 2 process having the high priority. Why it is a high priority? So sorry, this has a 6 priority. This priority. So he has a 4 and he has a 7, but he has a high priority than this one. Since a high priority, then who will enter? This P2 enter. The P2 has executed for how long? Up to next process. Next process arrival at 3. So this is executed for 1 unit. So 2 units has left out. After execution, he has arrived. He is higher than this P2. So again, P1 will be entered. So the P1 will be executed for few units. Few units means till the next arrival. Next arrival is at 5 o'clock. So no need to do anything. So up to 5 o'clock, it has to be continued. So the P1 executed for 2 units. 2 units has left. So once it is done, then this P4 has also arrived. So once this P4 has arrived, all of them have arrived. So as for this priority, we are going to execute it. And he has the more priority. Just see, this P4 has the priority. So P4 will be executed for 1 unit. That is from 6. This goes to 0 and this. Then what happens? The P3 has come fast. P3 is preempted because of P2. P2 is preempted because of P1. P1 is preempted because of P4. So like this, they are preempting. And who is starved? This process who has come early, still he is not getting a chance to be executed later. So that scenario is called as a starvation. Then how they are avoiding? They are avoiding by a technique called as edging. And what the edging says? After every unit, why don't you increase the processes, increase the priority of the processes, those who are currently present in the ready queue. Means the process P3 has come. Now I'll do it, look into it, how it is happening. The same data I will take with this edging technique. So the P1, P2, P3, P4, P5. And this arrival is same, 3, then 2, then 0, then 5, then 2. And priorities, basically it is 2, then 4, then 6, then 1, then 7. And its execution time is here. Execution time is 4, 3, 7, and 1 and 3. So what he says, let's take he has applied the edging technique. And what the edging says, after every 1 unit, after every 1 unit of time, you increase the priority. Then first who has come, just look into it. First P1, P3 has come, he has arrived. Since he has arrived, P3 entered, executed till the next arrival. Next arrival is 2 o'clock, so 0 to 2. He has done. So nobody was there. So while it is executed, now who has entered? This P2 has entered. Because P2 arrived, P5 arrived, and he has the high priority than this one. So that's why he will get a chance. P2 has arrived. While P2 is entered now, so the P2 has to be executed up to 3 units. 3 units. During these 3 units, who was currently present in the ready queue? This P3. So P3 का जो priority है ना, एक बढ़ जाएगा मतलब 6 will be reduced to 5. And he has already executed 2 units. So this 6 will be reduced to 5. Now at which time? At 3 o'clock, this processes arrived. P1 arrived, P2 arrived, P3 arrived, P5 arrived. And what are those priority? This is 5, 4, 2, and this 7. Then P1 will be executed now. When the P1 will be executed, what happens now? This processes has currently in the ready queue. ABA. Yes. So this one present, this one present, this one present. And you have not told one more thing. Sir, when P2 was executing, P5 was also in the ready queue. Uska bhi to priority increase karna chahiye. Yes. This priority also increased to 6. Now who has come? This P1 executed from 1 unit. That is 3 to 5. 3 to 5. So 3 to 5 executed. So now it is executed for 2 units. And during this 5, it has come. it has come now, but who are earlier present in the ready queue? P2, P3 and P5. All these processes priority will be increased. How many? 2 units यहाँ पर रुके हैं, सबका प्रायोरिटी 2-2 यूनिट बढ़ जाएगा. So इसका प्रायोरिटी कितना हो जाएगा? 2. इसका प्रायोरिटी हो जाएगा 3. इसका प्रायोरिटी हो जाएगा 4. Then who will come now? Whole thing I am executing so that you can know. Now who has come? This P5 also come. So P5's priority is 1, it's 3, it's 2, it's 2, it's 4. And which one will execute? P4 will be executed. How long? That is 1 unit only. So 5 to 6. So this is completed. But during this 1 unit, every processor's priority will be increased by 1. So increase by 1 means this goes to 3, this goes to 2, this goes to 1, this goes to. Now you know that all of them has the priority. Then which one will be executed first? Now very interesting part. This 2 has the high priority. If it is a same priority, but both of them are the same priority, then which one will be followed? SJ. As per the SJ, this is 2, this is 3. So who will get a chance? This P1 will get a chance. Okay, this P1 will get a chance. Since P1 will be get a chance, so first P1 will be executed, then obviously P2 will be executed, then P3 will be executed, then this will be executed. So what happens? He will get a chance. He should not be wait for a longer time. Rather, his priority is gradually increasing. He is getting a chance in the middle to be executed. But in this case, he is completely wait till last because all other processes are entering. But now at least you can say, while executing this one, okay, I'll complete this. While executing this one, now what happens here? After 1 unit, then this goes to what? 1 unit will be executed, 6 to 7. 6 to 7 means it is 1, and all rest of the processes will be increased their priority by 1. So this goes to 0, this goes to 1, and this goes to become 2. Now if you can look into it, this and this have the same priority. Even if he was earlier high priority, but now in the next turn, when this and this will become, among these two, both of them are the high priority. But he will get a chance first because his execution time is lesser than this one. But in the reality, this process is executed. So that is basically called as edging technique. And with the help of the edging technique, your starvation gets avoided. So that's why this is very, very important how to avoid this starvation. That is by a technique called as edging. And what the edging says, after a fixed unit of time, every processes, those who are currently present in the ready queue, their priority will be increased by certain unit. Okay, today's this much. So next class is very important, which is complicated. That is called as the round robin method.
सर
Yes.
सर वो जो XV6 का जो दिए थे वो
हाँ।
तो उसमें वो इमेज को रन करना वो ISO को
ISO का
इमेज फाइल वो XV6
ISO नहीं है, वो पूरा का पूरा देखिए एक C files it includes only C files. When you run through this demo, I have given how to run this. It will run and create a .o file object code and it will run the operating system.
तो वो जो मेक फाइल से कंपाइल किए फिर उसको मेक डॉट क्लीन और फिर QEMU क्यों किया है? क्लीन हो जाएगा ना फिर वो
वो क्लीन करके फिर वो करेगा, फिर से करेगा. Because previous things I am removing and again I am doing the new things. It will work. Okay, then I am ending. हाँ,
सर एक थ्रेड का क्वेश्चन रन नहीं हो रहा था सर. कैन आई शेयर 1 सेकंड सर?
1 second, yes, ask quick.
Sir, can I share my screen, sir?
I am closing. You share it please.
Just a second, sir. Okay. Post digital participant sharing screen, sir. Can you?
Sure. Yes, done. Have you done -LP thread where you are compiling?
Yes, sir. I have done, sir.
Okay.
Sir, can you see my screen, sir?
I am able to see.
Sir, this is the program.
Open it. This is you have created the P thread. T1 is null. F1 is a function. Void star you have to write now. Void star something.
Here, sir. No.
Fifth line. No, fifth line.
Okay, sir. Void star and something, sir.
Okay. Some kind of value. Now you run. It will run.
Sir, just a second.
Then, okay, that's why it is showing. See, you have
Sir,
to
no
take,
output, sir. I'm not getting any output, sir.
you go there because your parent is dead now. Your parent is quickly dead. What you can do, you write a scanf there in
Yes,
13th, in 13th line. In 13th line, you write a scanf. Scanf, something percentage D, some comma ampersand P. Okay. Comma nahi hai.
Yes, sir. Sorry, sir.
No. And you declare a P in PP. Now you run. I told in the last class, no, it was the parent is dead, that's why the child threads could not able to run.
Yes, sir. Got it. Thank you.
Because scanf at least you are waiting, huh?
सर वो जो मेरा कंप्यूटर में जो विंडोज में वो QEMU इंस्टॉल है,
हाँ.
then I have used that
6 मिनट पूरा हो गया. मेरा क्लास और एक अदर सेक्शन का कल डिस्कस करता हूँ, ठीक है ना? मेरा आज का क्लास कंटिन्यूअस क्लास है, इसलिए मैं थोड़ा लास्ट टाइम भी मांगा था आपसे टाइम ऐसा